Hi everyone, welcome back to PolyCloud YouTube channel. In this video series, we are covering the Microsoft Azure Administrator, that is AZ-104 certification, one of the most in-demand cloud certification in the industry. I will walk you through every Azure services from virtual machine storage and networking to identity management, policy and cost optimization with real hands-on demos and clear explanation. Complete series is designed to help you understand core Azure concept in depth, master real-world administrator tasks, prepare confidently for AZ-104 exam, and build a strong foundation for your cloud career. The best part is this entire course is completely free of cost, available end to end here on PolyCloud. I will also be uploading more Azure and DevOps and cloud courses soon. So please support the channel by subscribing and helping us to reach our first 1000 subscribers. It really means a lot and keeps this free learning going. Let's dive and explore Azure one service at a time right here on PolyCloud.
In this demo, I'm going to manage a blob shared access signature. Remember, there are two types of shared access signatures or SASs that we have talked about. We said that we could have a shared access signature at the storage account level for restricted limited access to the contents of the storage account, or we've mentioned at least that you can create a SAS giving access to only a single blob. And that's going to be our focus. Let's just take a look at this in the portal. I'll open up the left-hand navigator because I want to go to storage accounts. And I want to start by looking at the storage account SAS briefly. We've already talked about that. We'll just quickly review it. So I'll open up the storage account in question. And navigator, we're not interested in access keys because they provide full read and write access to the entire storage account. That's no good for our current need. We want to have restricted access to one blob. And we could go to shared access signature and create a shared access signature, limiting access to blobs, file shares, and whatnot. Shared access signature at the storage account level. Still not what I want to do here. Instead, I'm going to scroll up in the left-hand navigator and go into my blob container. I'm going to open up projects, and let's say that we want to allow access to one single blob. I don't want to enable anonymous access for the blob container or anything. I want authenticated access to one blob, not using an Entra ID user account, but using a blob SAS, a blob shared access signature. If I click on Project A to open up its properties, we can click Edit, and it contains 3 lines of text. Project A, this is change 1, this is change 2. Very simple. However, we have a Generate SAS tab that we can click on to the right here. That's where we're going. For the signing method, we can select account key for the storage account, so whether it's key 1 or key 2, or you can select user delegation key. When you use the user delegation key, it's tied to the current logged in user's credentials. That's my admin account right now. Well, I don't want to do that, so I'm going to choose account key. Key 1 is fine, and I can determine what permissions I want to allow, whether it's read, add, create, write, and so on. I only want read-only access to read the contents of this specific blob or this specific file. So just like a storage account level shared access signature, we can determine the date, defining when the shared access signature can be used, and of course the time on that date in a given time zone. We can also specify when, in terms of the date and the time, that the shared access signature will expire. The default selection is an 8-hour time span. I'll leave that. We can also specify from which IP addresses this shared access signature can be used, such as an on-premises environment or a single admin IP address. Of course, we know that IP addresses can be spoofed, but still, it's an additional security measure. It's kind of that layered security defense methodology. Having multiple layers of security definitely makes things harder to break into for the bad folks. So down below, I will choose Generate SAS Token and URL. Depending on what tool or what specific method programmatically might be used to connect to the blob will determine whether you need to provide whoever wants to read the blob with the blob SAS token. The tool or how they're connecting will also determine perhaps that instead they would use the blob SAS URL. The way we're going to test this is we're going to test accessing the blob simply by placing the URL in a web browser. So I'll copy the blob SaaS URL. I'm going to go into a completely different web browser session where I'm not authenticated to Azure. And when I connect to that URL, so it's connecting to the Project A URL, using my generated signature, it allows me in, no questions asked. So I have the contents of that file shown here. Compare that with going into the properties of that same blob and simply trying to connect directly to the standard URL for it. Let's go try that right now. So in another browser window, I've simply pasted the storage blob URL, the endpoint for that URL, and it says public access is not permitted. But using the shared access signature for the blob, it lets us in. That is exactly the purpose. Of course, it's only good for 8 hours based on our configuration. That is how blob level shared access signatures work. In this demo, the focus is going to be on working with a stored access policy for a blob container in a storage account. Now let's review a couple of quick things that are relevant to this. Just first, I'll open up my navigator on the left and go to storage accounts, and I'm going to open up the storage account where I want to work with stored access. We already know about access keys in the storage account, giving full read and write access to the entire storage account. We know we can generate a shared access signature at the storage account level and determine which services in the storage account, such as only blobs, can be accessed and what permissions are applicable for that type of service. We can have a start and end date and time of when the shared access signature can be used. It can be tied to an IP. That's fine. I'm not going to do that. I'll click the X. We also know that we can go into an individual and we could generate a shared access signature for it, for an individual blob. So in this case, it's for the Project B file. If we click Edit, it's got 2 lines in it. The first line says this is Project B, and the second line says this is changed data. Well, when you go to generate a SaaS, notice one of the things that is available is a drop-down list here for stored access. If I open the drop-down list, there's nothing in it. Okay, it seems that there's something else I should have done first. Okay, now it's time to define what the purpose of this is. We already know about signatures. We can already do this. So what benefit am I getting by using a stored access policy? Let me tell you by showing you. Okay, I'm going to go back to my projects blob container and I'm going to click access policy. You add your stored access policies. We don't have any here, and that's why the drop-down list was empty. We associate a stored access policy with a shared access signature, as we saw, only there were no stored access policies at that time. So let's click Add Policy. I'm going to call this one Reader. That's the identifier. So the permissions I will set here will be read, but notice the other permissions like list, delete, write, create. This would be for blobs. I can set just like a regular shared access signature when this should apply. So maybe starting today at noon, and maybe we'll let it go perhaps for another week. And so just like that, we've got a reader stored access policy, but by itself, it's not doing anything. I could click the context menu over on the right and edit it and delete it, but how is it used? Well, I think we know it's used when you generate a shared access signature. I'll click Overview on the left. I'll click Save at the top to save that configuration. Then I'll click Overview in the left-hand navigator so we can get back to looking at our blobs in the blob container. Let's go back into Project B again. And let's go to Generate SaaS. Now, if we open up the stored access policy, what shows up? Reader. If I select it, it populates the permissions, the start and the expiry date and time because it reads that from the stored access policy. So the stored access policy is being used to create or configure this blob shared access signature. So down at the bottom, just like usual with the blob level shared access signature, I'm going to click Generate SaaS Token and URL. I'm interested in the blob SaaS URL because we're going to test that we can connect to this from a browser that's not authenticated to Azure, not authenticated to anything. So I'll copy that blob SaaS URL. And when I paste it into some other web browser that's not authenticated to anything, it shows me the contents of the blob because it says this is project B, this is changed data. Now, you might wonder, this sounds an awful lot like using a blob level shared access signature, other than kind of injecting some settings from a policy. But the other thing that Microsoft says is great about this, and I agree with them, is that you can edit the stored access policy that's used by the shared access signature after you've saved the shared access signature and distributed it to other parties that use it, in this case to access that Project B blob. That's interesting. Let's check it out. So if I go back into access policy for my project's blob container, there's the reader stored access policy we worked with. Why don't I go ahead and click the context 3-dot button over on the right and click edit. One of the most common things done with this when it's used is to backdate the expiry date or time, or the start expiry date or time. Maybe we meant to start it earlier and have it expire much earlier. You can't do this with the shared access signature without creating a new one and redistributing it. I'm going to choose OK, and I'll click Save. So just like that, we've modified some aspect. It could have been the permissions, but we worked with the start and expiration date. And so if I go back into that web browser instance where we were able to read the contents of that Project B blob using the blob SAS URL, if we click refresh, now it no longer works. The authentication failed because it's not within the designated time frame that the stored access policy is using with the shared access signature. In this demo, we're going to explore the concept of replicating a storage account to a secondary region and how that all plays out if there's a disruption in the primary region. First thing we'll do here in the portal in the left-hand navigator is click on Storage Accounts. So we have a list of our storage accounts, and I'm going to open up an existing storage account called Store Account AZ-104. The overview page by default, and so over on the right under Replication, it says Read, Access, Geo-Redundant Storage, and in parentheses RA-GRS. RA-GRS means that the secondary replica of the storage account, the contents of it, can still be read even if the primary location is still up and running. The primary location here being Canada East, as it says over on the left. Further down, under disk state, it says primary available, secondary available. So they're in sync, and both replicas can be accessed. If I scroll down in the left-hand navigator, and if I click on redundancy on the left, the east is the primary region or location where the storage account exists. So it's in a data center somewhere in that region. And we've got a replica in Canada Central that is always readable. So it's showing Canada Central here as being secondary. And of course, it's also showing it on a map geographically to give us a visual sense of where those locations are. The redundancy here is set to read, access, geo-redundant storage, which we saw in the overview page. But from the drop-down list, you could choose geo-redundant storage, simply GRS. All that means is that, yes, we have a secondary synchronized copy of the storage account in an alternate location, but it can only be read if the primary location is unavailable. We also have locally redundant storage, or LRS, which only provides availability or protection if there's an equipment rack failure in a data center. Now I'm going to duplicate my browser window here, and I'll go home in the portal. I'll choose Create a Resource. Let's examine that option, the replication or redundancy option, upon creation. So if I go to create a storage account here in the portal, down at the bottom of the basics page is our redundant. It's set automatically here to Geo-Redundant Storage GRS. But we also have a couple of other options. We know about Locally Redundant Storage LRS. We also have Zone Redundant Storage. An availability zone generally maps to a data center within a region. So we can have zone redundant storage to protect against, as it says, data center failures. If you want to combine GRS and ZRS, that's what the GZRS option is for. So we have a number of choices here. Now notice that the standard performance tier is selected above. If we go with the premium performance tier and go to the redundancy, the only options we then have are LRS and ZRS. Okay, so that's kind of how that plays out when you are creating a storage account. We know we can go back and change it in the properties of the storage account. So back to our configuration, RA-GRS, read access. Well, what happens if the primary location, Canada East, for some reason is unavailable? Maybe due to a widespread power outage in that region. Well, what we would do is we would fail over to the secondary copy so that it's not only readable, but writable. So even if the primary region, in this case Canada East, is unavailable, you can still sign into the portal and manage the configuration for this stuff. So if I click Prepare for Failover up at the top, that the secondary endpoint, what's currently the secondary copy, will be switched to become the primary endpoint after you complete failover. It also states that we have a last sync date and timestamp. So depending on what's happening with data rights to the storage account when you do this, there is a possibility of some small amounts of data loss. It also says after failover is completed, you're going to end up with a locally redundant storage or LRS account. So down below, confirm failover, type yes to confirm. I'll type yes, and I'll click failover. So Canada East is currently the primary, Canada Central is currently the secondary. That will change when failover is complete. Okay, if we open up our notification area in the upper right of the portal, the account failover is successful. So what are we left with? For our storage account, notice the screen has been refreshed. And what's happened is that the Canada Central replica has become the primary. As we know, the account is now locally redundant storage LRS. In other words, it's only within one region. We can change that, of course. That is the default behavior. So what used to be the secondary is now the primary, which makes sense because the whole reason for initiating failover is because the primary replica is inaccessible due to some kind of an outage or some kind of a problem in that original primary region. Azure Cloud administrators need to be aware of how security is applied to a variety of Azure services. And that's why we're going to take a few minutes to talk about the CIA security triad. Now, CIA, we talking about the American government agency? Of course not. What we're talking about here is C standing for confidentiality, making sure that sensitive data is only available to authorized parties. Often, we use encryption technology to make sure that that happens. The I part of the CIA security triad stands for integrity. This means making sure that any sensitive data can be trusted in that it's authentic, it came from who it says it came from, and it's not been tampered with along the way. When it comes to technology, often we do that by verifying digital signatures created by the sender. The sender creates a digital signature using their unique private key to which only they have access. On the receiving end of verifying that authenticity, we would need the related public key, which can be shared with everybody. That public key verifies that the signature indeed was created with the corresponding private key. The A part of CIA stands for availability. Availability means that when we have important IT systems, services, data, that it be available when we need it. Often that comes in the form of doing things like having frequent backups, or maybe duplicating systems like having a load balancer cluster, such as having server clusters. If one server goes down, others are available. You could do the same kind of thing behind a load balancer with multiple back-end servers, maybe replicating data to alternate locations for safety. All of that falls under availability. That's what the CIA security triad is about. Encryption means that we are taking plain text or the origin data and we're basically scrambling it. We use an encryption algorithm, of which there are many, and we use a key. Together, the resultant output is called ciphertext. That's the scrambled data. So even if it's intercepted, it can't be made sense of. You would need the appropriate key to decrypt it. Now, if the data was encrypted with the recipient's public key, then the recipient will use the related private key to decrypt it. That's called asymmetric cryptography because you have two keys, but they're different, hence asymmetry. In other environments, You might have one single secret key, otherwise called a symmetric key. In other words, the key that's used to encrypt is also used to decrypt. That doesn't scale well. It's hard to find a way to securely distribute that secret key on a large scale. In Azure, we can create a key vault. A key vault is a resource, so you're going to need a subscription that you create, and it's designed to serve as centralized secured storage for secrets, like key pairs. In our screenshot, a key pair is being created, an RSA asymmetric key pair, where you could set details like the specific key size in terms of its bit length, when it should be active, when it should expire, if at all, whether it's enabled or not. And that key pair could be used for a variety of things, including encrypting storage accounts. When it comes to encryption and integrity in the Azure environment, transport layer security comes to mind, otherwise called TLS. When we have HTTPS connectivity to a variety of services, we need to have a couple of things in place. First of all, firewall rules have to allow that traffic. Normally uses TCP 443, but in addition, if it's a website, for example, a web server, it needs to have a PKI certificate. And thirdly, we need to use some kind of network security protocol suite to use that certificate and to encrypt the connection to the web server in our example, and also to verify that the transmissions haven't been tampered with. That's what TLS is about. It supersedes the old secure sockets layer, SSL, which should never be used, and you should be using TLS version 1.2 or better. There are just many known security flaws, so we want to stay away from those versions. You can determine the version of TLS a server is using in the web server protocol stack configuration, or in Azure in the app service configuration. On the client side, that can even be set in the client settings, such as in a web browser. But the best way to do it is to set the TLS version at the server and not allow it to accept any other types of connections, which would lead otherwise to what we call downgrade attacks. Then we have VPNs, which we've talked about, virtual private networks. They use both encryption and integrity to establish and use the VPN tunnel between the two endpoints. On the database side, you might consider things like SQL Server Transparent Data Encryption, or TDE, which is used to encrypt data at the database level. Of course, storage account encryption in Azure is also a part of this. In terms of Azure availability options, we can have database or storage account replicas that we replicate and keep in sync in secondary locations, other regions, in other words. So if I've got a database in the Canada East region, I can create a replica in the Canada Central region. So if there's a disruption, for example, in Canada East, perhaps due to a weather event and a power outage, we still have access to the data in Canada Central. Another availability example would be the use of application load balancing. Connections to a service or a web app go through the load balancer, which uses a number of back-end servers configured to serve up the same app. Well, if any of those back-end servers doesn't respond or crashes, the other ones will pick up the slack, hence availability. Or you could use Azure Site Recovery, otherwise called ASR backups, basically Azure Cloud backups, to back up data frequently so that data is available in the event of a problem, like a ransomware outbreak, heaven forbid that should ever happen, or in the event that data is simply mistakenly deleted or becomes corrupted. We have a screenshot of storage account replication. When you're in the properties of a storage account, in the left-hand navigator in the portal here, you can click on Configuration. Over on the right, you can then select what type of replication you would like, if any. In our screenshot, Read Access Geo-Redundant Storage, or RA-GRS, is set, which means that we would have a replica of the storage account and its contents copied to a secondary region and kept in sync, and read access to the secondary copy is automatically enabled if the first copy is unavailable. So these are some things to think about when it comes to the CIA security triad and how it applies in Microsoft Azure. We've talked about the importance of applying the CIA security triad to IT systems. And really, we're focusing here on confidentiality in the form of encryption. we're going to talk about how we can use customer-managed keys to encrypt our Azure Storage account. Let's poke around a little bit first in the portal. I'd like to go into the Storage Accounts view and open up an existing storage account. Doesn't matter which one. If I scroll down in the left-hand navigator and select Encryption, notice that the default automatic set encryption type, when you create a storage account, is Microsoft Managed Keys. You are getting protection for data at rest. But in some cases, you might need to have full control of the keys used for encrypting and decrypting certain types of data. Maybe in compliance with data privacy laws and regulations, or maybe to comply with contractual obligations. Whatever the case is, you have the option of working with customer managed keys. But a few things have to be in place first before you can do that. So let's discuss those ones. Let's go back home here in the portal. And what I'm going to do is open the All Resources view because I already have a Key Vault resource created. It's called KV East for. Notice the location, the region, is East US. If we take a look at the location or region for the storage account that we're going to encrypt with customer managed keys, we're going to use store account YHZ4. Notice it too is in the East US location. That matters. The storage account and the Key Vault need to be in the same region. So if we go back into the All Resources view, I'll just filter for what I know the name of that is, KV for Key Vault. If we open up that Key Vault, a few things have to be in place here. First of all, under Access Control IAM, create a Key Vault, you're going to have to go add role assignment, and you're going to have to assign the Key Vault administrator role to whoever the admins are that will be managing secrets in this. I'll click the X to close out of that. Now, secrets could be database, usernames and passwords. It could be encryption keys, PKI certificates. But in addition, that goes along with the access configuration on the left being set to role-based access control. That's the default, unless someone has changed it or it's an old vault that uses the old vault access. The other thing that needs to be in place is you need to have encryption keys. A key part of the keys view, I don't have any keys, so I'm going to choose Generate Import. You do have the option of importing keys if you have a key pair in a file, or you can choose to generate them, which I'll do here. I'll call it key pair. It's going to be an RSA type of key pair. It'll be 2048 bits. I'm not going to set an activation or expiration date because I want the key to be usable always as long as it's enabled, which it is, and I'll choose Create. So there's key pair 1 in KV East 451. Let's go back into the storage accounts view and let's open up store account YHC46. Once again, we're going to scroll down on the left until we get to encryption, and we're going to choose customer managed keys on the right. We have a link to select a key vault and a key, so I'll click that. That opens up a new screen. You select the subscription where the key vault is, and you would choose key vault unless you're using managed HSM, hardware security module. HSMs are tamper-proof cryptographic devices that specialize in securely performing cryptographic operations, including the storage of keys and the use of keys for encryption and decryption. You might be required to use HSM in the cloud to be compliant with certain security standards. In this case, I'm just going to choose. When I go to the Key Vault drop-down list, these are the key vaults that are available in the East US region. So that's where this storage account is. There's KV East 451. If I open the drop-down list of keys, there's our key pair 1. Now, if you've just created a key vault and you come in to do what I'm doing here in the storage account, it might not show up in the list of key vaults for a while. Be patient if you've just created the key vault. Sometimes it takes 20-30 minutes, I've seen in some cases, before it'll be available in that list. So as long as you know you've done it correctly, don't sweat it. Okay, I'll click Select. Now the next thing we have to consider is the identity type. Azure is going to create a managed identity for this storage account. What is that? Think of it as being a dummy user account that represents this storage account. And then that way we have a way to assign permissions to the storage account, because the storage account is going to need permissions to retrieve keys from the key vault. A system assigned managed identity means that it's tied to this storage account. So if you delete the storage account, the managed identity goes away. User assigned means it can be associated with this storage account, but if the storage account is deleted, the managed identity would still remain and you could associate it with something else. At any rate, I'll leave it at system assigned and I'll choose save. Now, notice it says down below, your system assigned identity does not have access to the key vault. Okay, well, let's open up another browser window here and let's go to the All Resources view. Let's open up our key vault. I'm going to go to Access Control IAM where we can add role permissions. I'll choose Add Role Assignment over on the right. Now, there are a number of key vault built-in roles, which are collections of permissions. For example, the key vault crypto service encryption user allows for reading keys and performing wrap-unwrap operations. That's what we're going to use here. I'll choose Next. But what I want to do is make sure I assign access to a managed identity. I'll choose Select, and I'll specify a storage account as the managed identity type, and then I'll choose my storage account, store account YHZ46. Select. So I'm giving the storage account access to keys in the key vault. So I'll review and assign that, and I'll go back into our storage account configuration. We're still on that same screen where we were trying to save the customer managed keys configuration. I'll just click Save again. This time it liked it because the storage account had the ability to go and read the key that we specified to use. So at this point, we have now successfully configured the use of customer managed keys for encryption of our storage account. In this demonstration, we'll be managing service and private endpoints. The focus will be on private endpoints in a storage account, but we need to distinguish the difference between a service endpoint and a private endpoint. What is this all about? Well, a service endpoint allows you to refer to a type of Azure service, like virtual machines are a compute service in Azure or storage accounts as a whole. So a service endpoint configured for a subnet would allow that subnet to contact, let's say, storage accounts in Azure using private IPs going over the Microsoft Global Backbone Network. But what if we want to limit that to a single instance of something like a storage account? That's where private endpoint comes in. So it's a resource that you actually create in Azure, a private endpoint is. And what it will do when you configure it is it will create a virtual network interface, just like you would have for a virtual machine, that's tied to a subnet. So the storage account is sort of injecting itself into the subnet through that network interface. So whatever is on that subnet would be able to connect to that single storage account through the private endpoint. So it's a private IP address, it's not a public one, and therefore traffic doesn't go out on the internet when contacting the private endpoint from within that subnet. Instead, it uses the Microsoft Global Backbone Network. And so let's make this happen. I'm going to go into my storage accounts view here. I'm interested in a storage account called store account YHZ44. Now let's say I need that storage account to be visible only to a specific subnet. Not all storage accounts, so not a service endpoint, one storage account, so a private endpoint. Now, not only do I want it to be available to just one subnet, but I want it accessible via a private IP address, and I want the network traffic to go over the Microsoft Global Backbone Network. So again, private endpoint. If we go to our virtual networks view, I've got a virtual network here called VNet2, and if I go to the subnets view, we've got all kinds of subnets. So what I'll be doing is injecting this into subnet. What that means is that I might have services running in subnet 1 or virtual machines with code in them, whatever it is, that need to access the storage account. And I want to do that as securely as possible. I don't want the storage account accessible from every network, including the internet. Okay, so let's go back into our storage accounts, into the storage account in question. And what I'd like to do is scroll down, and on the left, under Security and Networking, I'll click Networking. Now, you can configure all of this when you're creating the storage account, or as we are doing, after the fact. The default selection when you create a storage account for public network access is to have it enabled from all networks. That means anybody from anywhere can potentially try to access the storage account, including from the internet. This storage account is currently configured to be enabled from selected virtual networks and IP addresses, and that's been done down below, specific subnet. Well, I'm going to choose disabled because yes, I do want this storage account only available to services on a subnet, but using private IPs. So I will disable that, save that configuration, and it tells me that public network access to the storage account has been disabled. Please create a private endpoint connection to grant access. That's where we're going. I'm going to go to private endpoint connections at the top. I don't have any, so I'll click the Add Private Endpoint button. Remember, a private endpoint is an Azure resource, so it's going to be deployed into a resource group. For clarity in this example, I will name it store account YHZ44_priv_endpoint. And of course, it's going to make a corresponding network interface as we know. The region will be East US. I'll click Next for resource. The target sub-resource drop-down list, I want to allow access through this private endpoint to the blob service, so to blobs, within my storage account. Next, virtual. Well, I want to tie this to VNet 1, subnet 1. So subnet 1 has a range of 192.168.1.0. So you can create a private endpoint and the network interface will acquire an IP from the subnet range. And you can add multiple endpoints for different subnets, such as VNet 2 and so on. For now, we'll just leave this on VNet 1 and subnet 1. I'll leave the other settings as they are and I'll click Next for DNS. I'll leave it integrated with the private DNS zone, so it's going to make a private DNS zone with an A record to resolve the name of the storage account to its private IP. Next, tags, nothing here. Next, review and create. And once the validation has passed, I'll just click the Create button in the bottom left. All right, now the deployment is complete, so I'll click Go to Resource. Now, the resource we're going into is the private endpoint. And in the Overview blade, which is selected on the left, over to the right, we see that this is in VNet 1, subnet 1. We see the network interface it's associated with. And interestingly, if I were to go to the VNet level, so Virtual Networks View, let's go into VNet 1. First things first, of course, if we go to subnets, that's where all of the subnets are. And subnet 1, remember, used the 192.168.1 range. So if we go to the Connected Devices view on the left for VNet 1, private endpoint network interface is shown here, and it has acquired an IP address within the 192.168.1 range. In addition, if we were to search for DNS in the search bar at the top of the portal here and go into private DNS zones, we've got a private link.blob.core.windows.net zone. Remember, we elected to integrate our private endpoint with the DNS zone? And so now we've got an A record for store account YH, that's the storage account, with its related private IP address. Access to storage account contents. We did this by managing storage account access keys with the portal, the CLI, and PowerShell. We also managed storage account shared access signatures and blob shared access signatures. We also created a storage access policy and we replicated a storage account across regions. Following that, we discussed Azure Encryption and we encrypted storage accounts and managed service and private endpoints. In our next course, we'll move on to explore how to deploy and manage Azure Files shared folders.